Okay, so for part 2, these problems are gas stoichiometry problems. So they're combining what we did in part 1 with our ideal gas law, which we learned in the past couple weeks. So whenever you do a question like this, I always want you to write out your givens in that little chart that I have for you. So it says in my problem that my pressure is 970 torr. This is question 1, by the way. It says my volume is 15 liters. My temperature is 21 degrees Celsius. However, I always want to turn that into Kelvin by adding 273. So I would get 294 Kelvin. And then I always know my R, which is my gas constant. And so if you look at the table right above question 1, in the middle section where it says ideal gas constant, there's 3 options. You want to pick the one that matches your unit of pressure. So for this problem, we're going to do 62.4 because in its unit it has torr, which is our pressure unit. Okay, then you're going to ask yourself, do I have enough information to solve my ideal gas law problem? And you do, because you have 4 pieces of information and you just have 1 that's missing, so we can easily solve for that. So we're going to plug all of this into our formula. So pressure is 970 times our volume equals N, which is what we're going to solve for, times our R, times our temperature. And then we just need to get N by itself. So let me grab my calculator. So I like to simplify my problems first. So I'm going to multiply these 2 numbers on the left. And then I'm going to write that underneath. Equals, I'm going to bring down my variable because I don't know what it is yet. Then I'm going to multiply these 2 numbers. And write that underneath. Okay, now to get N by itself, since it's being multiplied by this number, to get rid of it, we have to do the opposite, which means divide both sides by this number here. So I divide both sides. It cancels out on this side, and I'm left with N equals, I'm going to plug this into my calculator, 14,550 divided by 18,345.6 gives me 0.79 moles. You can go ahead and round it to the first couple decimal places. So after this, I'm not done with this problem because my problem wants me to figure out grams of aluminum oxide, which is Al2O3. So this is what I want my end result to be. So I'm going to use what I just found using my ideal gas law to find what I'm looking for. So what we found was our moles of our gas, which was O2. Because anytime you use the gas law, this only applies to gases, and the only gas we have in our equation is oxygen gas. Okay, so we have our moles of O2, and we are going to solve for grams of aluminum oxide. So similarly to how we did in part 1, we are going to set up our chart. Our given is going to be what we solved for, 0.79 moles of O2. So we are starting here at moles of A, and we're trying to get to grams of B. So I bring my unit down. I want to convert moles of A to moles of B. So on top I'm writing moles of my B, which is Al2O3. I use my mole ratio. So in my balanced chemical equation, I have a coefficient of 3 next to my oxygen, and I have a coefficient of 2 next to aluminum oxide. So it's a 2 to 3 ratio. Okay, I haven't found what I'm looking for yet, so I'm gonna keep going. Bring my unit down. Okay, and then I can convert my moles of B into grams of B. So I'm gonna put grams of Al2O3 on top. And then this is a molar mass conversion. So for every 1 mole of aluminum oxide, I would put its molar mass here, which, let me see. If we add that up on the periodic table, it's gonna come out to be about 102. And then since our unit matches what we're looking for, we can go ahead and solve by multiplying all the numbers across and then dividing it by 3. And that would give us our final answer, which we'd put in our solution box. Okay, for our second problem on there, we are doing the same type of problem, but we're given different information. So you're always going to start with listing your givens, just like we did in question 1. So we have our, let's see, temperature says 25 degrees Celsius. However, we want to convert this to Kelvin. So if we add 273, we would get about 298 Kelvin. And then our pressure is 800 torr. And then it also tells us 28 grams of aluminum, but that doesn't help us for our gas law. So we're gonna leave that for later. We always know our R, and since our pressure is in torr, we're gonna choose the R that matches, which is 62.4. And so this is everything that we know so far. So you ask yourself, do I have enough information to do my ideal gas law right now? And the answer is no, because you're missing 2 pieces of information, and we can only solve for 1 at a time. So this is gonna be our second step. We're gonna have to start with our stoichiometry first, okay? So draw your chart. It tells us in the problem that we have 28 grams of aluminum, okay? So that's our given that we're starting with, and we're gonna solve for moles, okay? Because our very, very end goal is to find the volume of our hydrogen gas. And before we can solve for this, we need to know our moles. So we're going from grams of aluminum to moles of hydrogen gas. Okay, so try this stoichiometry problem on your own. Your end answer will give you moles of H2, which you will then plug in to your N value to solve for V. Okay, so whatever number you get here, you'll plug that into your PV equals nRT, and whatever answer you get there will be your final answer in your solution box.